All right. Hope everybody enjoyed lunch. Nobody ever wants to be the person who presents right after lunch, because within 20 minutes, you guys, the topper will set in and you'll be sleeping. So I'll try to keep this as exciting as possible. We are still talking about storage, so it's not all that easy. But my name is Glenn Deckhazer. I am a global principal with Equinix. And Equinix, as you may or may not know, I'm not going to drain the slide. This is more for people who are going to download the slides later. We are the world's leading digital infrastructure company. We are not a storage company. What the heck am I doing here? Well, hopefully by the time I'm done, you'll figure all that out. But essentially, we've been around since '98, and we've developed into the company that the largest of large firms in the world come to build their digital transformation efforts. From a storage context, most of the storage companies come to work with us because they see cloud adjacency, and I'll get into what that really means. But typically the storage companies that come to work with us don't really know what that means. And so, and many of the large companies, from a data and storage perspective, don't really understand what digital infrastructure means to them. And especially with the things going on with generative AI, with hybrid multi-cloud, and a lot of things I'm going to discuss, it's extremely important to understand the context. And from a storage developer, product manager, product development perspective, it is most important to understand how customers are using your products in the new world that we have a great perspective on. So to give you an idea of where we see everything from, right? The black dots represent where we have data centers, and some of those dots we have multiple data centers. Those are all metros, okay? And you'll see lines that connect them all. So what we do is we provide the locality as well as the interconnectivity for these global enterprises to perform digital transformation, right? Now, these are all big, high-level terms. I have not once mentioned RAID or storage or framework, right? We'll get there, all right? But this is important. This allows us a perspective that from a single storage vendor's view, or even from a specific enterprise's view, the perspective that we get from having that vast of a landscape, we get to see what all the customers are doing across all the vendors. So what I hope to do is to give some of the things that we've learned, some of the predictions that we made that have come true that we actually see customers doing. I want to hopefully can let you guys leave the room with some of that. And the digital transformation, I'm not going to get too much into the marketing thing, but we found that we provided frameworks for customers for doing digital transformation, and it involves for customers to build a digital edge, digital ecosystem, which involves all the partners and services they're connecting to, as well as building a digital core. And that digital core we're going to focus on really quick. Now, the title of this presentation is the Authoritative Core Design Pattern. So what we're hopefully going to impart on you today is how are customers using storage and data management applications to create architectures, the optimal architectures for them, not just regionally but globally, that answer for all of the things that they're being asked to do from a compliance, governance, sovereignty, performance, all those competing things from their perspective. How are they creating the outcomes given that it's a changing world? And then, of course, we add on now this new gold rush with AI and generative AI that's going to make this exponentially more difficult. For the purposes of definition, an authoritative core is a logical construct. It's not a place. It could be multiple places, but it's a logical place, and you'll see this in visual form, of localities, fancy way of saying places, and digital assets that can be storage, compute, network, data, cloud, service providers, where data is stored in aggregated form, updated and distributed from. We'll talk about how that manifests itself. And the reason that this is done is to create optimal hybrid multi-cloud outcomes. That can also be edge to core to cloud, which is another form of hybrid multi-cloud. You probably heard both of those terms, all right? So hopefully, by the end of this, and I hope to leave a lot of time for you guys to hammer me with questions later. The reason we came here to talk about this topic is we believe it's important for storage vendors to understand their role in the customer outcomes when it comes to hybrid multi-cloud, edge to core to cloud. My role as a global principal is I get to speak to all the storage vendors around the world, kind of subject matter expert for our global storage practice. And storage vendors come to us all the time and asking how we want to work with you. How do we work with you best? They don't understand, they know they need to be with us, but they don't necessarily understand why, right? In order to do that, it's important for the storage vendors to understand how customers are now using their stuff to affect better hybrid multi-cloud outcomes. They are figuring it out on their own. The storage vendors aren't necessarily helping them here, all right? But if you're developing the products in the lower layers, understanding how they're doing this, hopefully will inform how you develop and engineer your own products, right? And by the end of this, we're going to talk about what patterns we are now seeing, design patterns, that customers are now implementing to affect these outcomes. First, let's talk about hybrid multi-cloud, because there's been some language I've seen out there that hybrid multi-cloud isn't really a thing. It's a marketing term. People want it to happen, but it's really not. Everyone's going to one cloud. The cool thing about at Equinix, again, our perspective, is we do get to see the realities. Hybrid multi-cloud not only is a thing, but it is accelerating, and that acceleration is accelerating, okay? You're going to see, and again, these are studies that we either funded or I borrowed, but this one is one we funded. Organizations using 4 or more public cloud infrastructure as a services is going to increase by a lot, right? So think about that. The average number of public clouds that the global 2000 uses today is 2.6. There's a joke in there on who the 0.6 cloud vendor is going to be. I'll let you guys finish that joke. But why is this happening? So roll back the clock. We've got companies that went into the first lift and shift, right? And all the storage vendors in this room remember how scared everybody was because, oh my God, now everything's going to the cloud and customers are getting rid of their data centers, and who are we going to sell to? We can't just all sell to the cloud service providers. They're going to take all the business. Well, that phase happened, and it turned out that enterprises didn't get the value out of that they thought they were going to. It was like 70% of CIOs that were polled said, you know what, we went, and the money we're spending on the cloud, we are not getting our money's worth. And so over the last 18 months or so, we've seen a great shift for a lot of workloads coming from the cloud being what's called cost rationalized, okay? And what you're going to start to see now is just like you'd see it in development and agile frameworks, you're going to see a continuous optimization of infrastructure now that enterprises are learning how to take workloads that were in the cloud and do similar things with different kind of financial constructs outside of the cloud, right? Certain vendors, there's vendors in this room, I think even, HPE and Dell and Cisco, they figured out how to take their hardware and create OpEx outcomes, right? Again, not talking about storage yet, I'm getting there. But the point is that this cost rationalization means that I'm going to take workloads out of the cloud and I'm going to put it on hardware that I control. Probably the bigger impetus for this is the growing, let's say, disconnection of the world from a technical perspective. We've got, when the internet first came out and, roll back the clock 10 years, we were sending data across the world and nobody really cared. GDPR came out, and Germany did better. Canada's got one. Obviously, China's got theirs. Australia's now got theirs. You've got Singapore and you've got Korea with theirs. The world is starting to separate, and control, governance, sovereignty is becoming one of the biggest conversations within security groups and compliance groups, audit groups within these major companies. Because of that, Auditability is becoming probably one of the biggest drivers of data coming out of the cloud or not going in there in the first place, right? I need control over my data. And the term for this we're going to use is data custody. Real custody of data. The cloud folks have redefined data sovereignty just to mean that I control the keys and I control the access. Therefore, that data is sovereign even if it's up in the cloud. I'm sorry, that doesn't cut it. You need auditability down to the firmware level for data storage devices that are holding the data that is going to be compliant. So that is where data custody comes in. So customers are now asking, I need to have data custody, all right? So I can't have it in the cloud, but I still need to use things in the cloud. The cloud isn't going anywhere. I'm not claiming that cloud is going to die because of all this. Not at all. It's still going to grow at a rapid pace. It's still going to get used, but customers need to have this ability to have data custody. How can I do both at the same time? Obviously, you still have the business drivers that are going to accelerate this stuff. IoT doesn't happen in the cloud. IoT happens on my premise or on a far edge device. That data is going to get generated. It's going to go to something over a network that I probably need to have under my control. Not everything is going to go over the internet. Why? Because if it goes over the internet, I have no determinism of path. I have no idea where that packet's going to go. If I'm in Canada and I'm in a regulated environment and I create data in Vancouver and I have to send it to Toronto, if I send it over the internet, that packet can dip, maybe into the States under Patriot Act territory. Not going to fly. It goes against regulations in Canada. So how do you deal with all that stuff? Private interconnectivity is required, all right? All of this stuff obviously speaks to what business that we're in, but again, in context of for hybrid multi-cloud, what I'm doing here is saying that if there's any doubts that hybrid multi-cloud is real and that customers are doing it, that should be dispelled. That does not mean they know how to do it, because they don't. And that's a big gap. That's something the storage industry, I believe, has a great role in helping here, because the storage industry has all the technology required, both at the hardware level and the software layer, in upper level functionality that's provided to solve these problems. And customers are starting to figure this out on their own. Yeah, expect that. So all the stuff that I just said alludes to the fact that data has conflicting personality. Today, given all the things going on, data wants to be consolidated, but it also needs to be distributed at the same time. This is a problem, because how do you do both at the same time? Of course, this is what the storage industry has been doing for a long time, right? Having copies of data either at the edge to do, let's say, let's talk in the world of AI. I need to do inference. That's going to happen at the edge. I need to do training. That's going to happen in some core or perhaps in a cloud. I need to do tuning. That's going to probably happen somewhere in the middle, maybe in a tune. Well, data, it's all the same kind of data in different formats, but it all has to be all over the place. It has to be managed, has to be secure, it has to be encrypted, it has to be masked. All these different things that have to happen to this data. But, you know, who is affecting those things, and how? The real trick is, how can we do this while optimizing infrastructure, management capabilities, and most importantly, cost? All right? So what we show here is the way that things used to be, right? Customer had a data center, right? Maybe they were in Sterling Forest, right? And that was their production, usually DR, but let's just say their production was in Sterling Forest and or in Colorado. Let's say it's in Fort Collins, Colorado, which looks like that's where that building on the left is. And essentially, they'd have all their networks coming through, very expensive lines, and that's how it was done in the past. And all the data processing was done in one place, kind of easy to do, and really you only sent presentation level stuff to the outside world. That's no longer what's going on. What's going on now is customers are now figuring out that they can have a distributed topology with their data all over the place, regionally connecting their branch offices, end users, customers, clouds, in these regional ways. So now, what that implies from a storage perspective, I've got to have storage in each one of those three places, and they kind of have to talk to each other. And then maybe I have to get data out to the regional offices for other things, right? The implications of this are, you know, from a storage perspective, are challenging. But why are the customers doing it? Because what they found is by doing this, they're reducing their costs for their networking tremendously. And that's a huge OpEx expense that gets cut out, right? And also by getting users and applications and service providers closer to where their application workloads are running, performance is increasing, they're getting better outputs, better outcomes. So the storage industry has to, kind of catch up to that. Right? So we're talking about not just, again, the cloud strategy is also kind of the most important because the way the cloud vendors aren't everywhere. Newsflash, they're concentrated in certain areas. They're on the West Coast in California or up in, say, Portland. You're looking in Virginia, you got some in Dallas and Chicago. And if you look at the other regions in EMEA and APAC, it's a similar paradigm. So they're not necessarily going to be where the customer data center is, or even where the customer's end users are. So how are we getting data moved all around to this place so that we can enable these optimal outcomes, right? It's really for best outcomes from a business opportunity exploitation perspective. So the biggest challenges from our perspective in the storage industry really come down from a multi-cloud perspective. If I've got, and I can speak to a personal experience I had with a company that was a video processing company. They had 30 petabytes plus of video storage, and they were using a specific cloud vendor, I'm not going to name them, using their object storage in Frankfurt, Germany. 30 petabytes, okay? Now, they wanted to take that data, and there was a new service. This is right at the start of like the AI boom. They wanted to use one of these newfangled AI services and extract some great value out of these videos, and it involved them moving it out to Chicago. So whether they were going to, kind of snowball it, I'm saying that as a general term like Kleenex, snowball it out of the cloud, or actually transit it, it was going to cost them about $1.2+ million just to get the data out, not to count the time it would have taken to do so. Now, I don't know about you, but if I'm someone who's saying, I want to try this thing out, and it's going to cost me $1.2 million to try it, chances are I'm not going to try it. So what they ended up doing was doing something that they considered it suboptimal in Frankfurt, and now they've got 45 petabytes in Frankfurt. So the next time a decision comes up, guess what? It's going to be more painful. Right? I like to call that a data singularity. You've heard of data gravity? That's a data singularity. It's turned into a black hole and it's just sucking everything else in with it, right? So that 1.2 million would have been 6 million if they tried to move it over the internet, by the way. That's an already optimized cost of transit of 1.2 million. Moving stuff over private interconnectivity costs a lot less, by the way. It can anyway. And again, we're not even talking about the time, right? The other thing operationally about multi-cloud is that AWS versus Azure versus Google, I just use the top three, they all have different operational paradigms, complete different operational APIs. So I can't, if I got used to using AWS, I can't just port everything I did and go to Azure. I got to completely redo all my, if I'm using any, Terraform or Ansible, whatever I'm doing for my automation, I got to completely redo it. I got to, it's a lot of work. It's very expensive. And so, that's why a lot of people, when multi-cloud first started becoming a thing, saying, you're really not going to do it. It's too hard. Well, when business requirements push really, really hard, it happens, okay? Especially when it comes to hybrid multi-cloud, the other thing to think about, as the CIOs start to saying, I'm spending a lot of money in that cloud provider, I'm not getting my value, I've got workloads running like VMs and just plain infrastructure as a service instances, 7 by 24 by 365, and they're just eating me up alive on a cost basis. I need to get those out. Where are you going to put them? You can't put them back in your data center if you even still have one. Because you built everything in a cloud region, there's going to be application dependencies between that VM and everything else you still have in the cloud. So you're going to have to migrate that thing close to where, adjacent to where that cloud region is. It kind of informs where you're going to put your stuff. Again, I'm not selling Equinix. Any co-location provider that has the adjacency to these cloud vendors would be an appropriate place to put this, right? We're going to talk about the design patterns and how those design patterns address these specific issues, right? So the purpose of the patterns we're going to discuss that I really want storage folks to ingest and kind of ruminate on and figure out what really means to you. It may mean nothing to your specific world. The vendors themselves, it does have a big impact, but I figure having this kind of high-level context can only help. First, how do we build an architecture that can eliminate the idea of egress for any future business decision a customer is going to make? That's a big ask, right? If I'm going to use Amazon or Azure or Google, when ingress is free, egress costs, right? Can you imagine how successful the cloud world would have been if they actually did by cost and ingress and egress cost the same thing? It would never happen. You'd never put loads in the cloud. It costs you too much, right? So they get you in, but they get you on the way out. How do we eliminate egress? How do we solve for the customer requirement of data custody, the control of that data? Customers need to be able to audit at least a good chunk of their workloads, the crown jewels of data, the financial data, any kind of proprietary IP, patient health information, the stuff that we need to protect on the storage side through encryption, masking, and that kind of stuff. How do we allow them to have custody of that data so they can prove to whoever's asking that, yes, I've got that data, it's what it should be? How do we allow for the flexibility of having workloads either on my stuff, on cloud stuff, on edge stuff? How do I provide for all that? And how do I put myself or put my customer in a position to, whenever a new opportunity comes up to either exploit a new service or do something new or buy a company and incorporate them, how do I put them in the best position to do that non-disruptively, right? And then lastly, as a function to do all that, how do I allow for, from a technical perspective, a dynamic way for all of my data to move around? Okay? Now, I'll add to that, from a storage perspective, the storage industry has talked for years about data fabrics. All right, there was one vendor who came out with it and trademarked it, but then it's become a more industry standard term, data fabrics. Now, the reality is that the storage instances of a data fabric are really only the nodes. They're not the fabric. The fabric is the interconnect between those. And storage, for too long, has ignored the dynamic of interconnection between, right? And it's actually how I got to this company when I was doing implementations of these data fabric type of solutions. And I would do on-prem solutions, instantiate cloud versions of the storage solutions, and try to get them to talk together. And of course, it assumes the interconnect is there. The network guys had it solved, right? No, it never worked. And so the ability to be aware of where my storage is and how it will interconnect to the different pieces of the puzzle, which you'll see in a second, I believe is an opportunity for the storage industry to do something new and valuable for customer outcomes, right? So the two pieces, the two main ingredients that the storage industry needs to start thinking about is inside the products. First is end user data custody and locality. So custodial locality is it's like in the customer's place, that's where the data custody is. And how can I consume the new paradigm of agile multi-cloud interconnectivity? There's a lot of ways to do this now that didn't exist 4 years ago, right? Where you can now call an API and instantiate a direct connect to Amazon or express route to Azure and tear it down, right? Think air gap or things like that, right? So here's a busy diagram, and I'm going to stay here for a minute. And this is essentially what the idea of the whole core is. I'll start from the beginning. So again, the authoritative data core is the place in the center that will say that the customer can control not just the data, but the storage it's on, the location it's stored in, okay? And that core in a given region, let's say this is the America region, would have, say, two, your standard primary, secondary, or 50-50 active-active type of location. And that is where the copy of the data, if at all possible, that gets updated from, say, IoT or end user access, perhaps your ERP databases are there and your instances are there. And the authoritative data core really represents where the data is, not the compute that hits it. I put that to the side for a reason, because you could have compute that's a baseline compute that's always there, and then you could also burst with a bare metal capability that's available in most of these locations. This data core, you'll notice, has a northbound and a southbound agile private interconnect. Same technology, essentially, used different ways. Let's start with the north, because this is about the hybrid multi-cloud. This is kind of the one that's more interesting to enterprises that I speak to. So the point of having that core is, how do I get the data that's in that core into the cloud and avoid egress? How do I do that, right? If I am that lift and shifter, phase one, I put all my data in AWS. And, so to that company in Frankfurt, they would say, well, when should I implement this? I'd say the best time to have implemented this was when you started. The second best time is now, all right, because it's not going to get any easier. But the point is, having a copy in the core allows me to do 4 different data motions that I know for a fact storage companies in this room implement today, right? The first and probably the most, I'll say, often executed that I've seen is what we'll call a project and delete motion. So I've got a data set, let's say I've got a data lake in a data core, and I want to go take that data, that raw data, I want to send it up to a cloud provider, and that's where I'm going to do my training, right? I'm going to keep it in the AI context, because right now that's what everybody's thinking about. But there's a lot of other reasons to do this. So I now move my raw data up into, let's just say, AWS. It's a read-only copy. My authoritative data core is where the read-write copy is. So if I've got data coming in from my edges on the bottom, and they're going to go update that with new IoT, I get that into the core first, then it goes from the core to the cloud. And again, it could be complete in-storage replication, could be assisted by external data management applications. Doesn't matter how it happens, but a read-only copy gets sent to the cloud. The reason you want to do this is, when I'm done with my training, I don't have to extract that data from AWS and incur egress. I can just delete it, and I'm done. My data is still at the data core. And I could leave it in AWS for an extended period of time. If I'm going to use that service for a period of time, you need 2 copies anyway under 2 different management planes. It's best practice. So 1 copy is going to be in my core, 1 copy is in the cloud. Great. Let's say AWS, is coming down the pipe. Oh, they're going to raise their prices. Or, you know what? I want to try Google's service. It seems pretty cool. I can easily try Google's service by taking another copy of that data or a subset, sending it up to Google, replicating it using storage, using one of the applications, and now I've got it set in Google. If I like it, I send more data up there, I kill AWS, no egress. I've now satisfied 2 of the customer's concerns. I now have my data where I want it in the new service. I've attacked the new opportunity, and I've avoided egress. Those are 2 of the precepts. And by the way, I've got my data in the core that I can now audit. That's the copy that matters. 3 precepts, right? I've got data custody. So that's just from one of the motions. Now, all 4 of these motions support the same set of goals, right? The second one we'll call utilize and place motion. That's the classic cloud adjacency. So if you guys have heard of cloud adjacency, it's basically where you've got compute in the cloud, and we're going to go hit the storage in colo, right? Everybody thinks it's a great idea. And when it works, it's great. But keep in mind that the connectivity from the core to the cloud is somewhat limited. Right? Normally, when we're talking about storage and talking to compute, we like to have multiple 100 gig interfaces, right? We like throughput. That can happen, not in an agile way, at least not yet. It's getting better. The most now we have in an agile interconnect between, say, a colo and and cloud, we have a 50 gig. One vendor is providing 50 gig today in limited places around the world. So, and it's not cheap, by the way. So the point is that if your storage need doesn't require a lot of throughput, maybe it's just latency sensitive, right? The latency profile from that cloud to this core is less than 2 milliseconds. Right? So we're not talking 0.5 milliseconds or 100 microseconds here, which is a lot of the stuff we like to talk about here. So we have to be realistic as to what the capabilities are. So utilize in place is a classic cloud adjacency. It works when it works. Project and delete becomes a more possible thing because now I'm going to actually move my data where it really is low latency and I can get it into a better paradigm. So, and cache to cloud, number 3, is kind of a mix between the two. There are there's a storage vendor I was just talking about yesterday that basically they put a cloud version of their storage operating system up in the cloud, and it's essentially on cache misses, it pulls the data up and works in that way. So cache to cloud is just essentially a combination of motions 1 and 2, right? Where I'm still going to delete the cache copy in the cloud when I'm done, avoiding egress. So 1 through 3 completely eliminate egress. We are seeing customers, I'm going to go through some use cases, customers are really doing this. This isn't just a diagram of hope. We are actually seeing customers on their own, without talking to us, doing this in a big way, with very large numbers of petabytes. The last one, number 4, is a little bit different, because what happens if you create the data in the cloud? There's no avoiding egress when you're doing that, okay? But how do we mitigate it, all right? So the old joke, how do you eat an elephant, right? One bite at a time. That's essentially how this works. What you need to do in order to use pattern number 4 is use some sort of deduplication technology, either in storage, of which there's many storage technologies out there that have built-in deduplication, or network level deduplication from a WAN dedupe vendor. A couple ways to slice this, but the end goal is to incrementally forever move data as it's updated in the cloud out to the core and use the deduplication to compress and deduplicate that data at a variable length dedupe if possible to get it to about a 96 to 97% reduction of egress. And when you're doing that, and you're doing that over time, you don't feel it. But the point is that you're still, while you haven't eliminated egress, you're still holding to the goal of making sure that egress doesn't get in the way of a specific decision to do something. That's important, right? Because if my data is already out, and I've eaten that little bit of elephant over time, it's now out, I can do what I want to do. If I did not do that, then I'd have to make that $1.2 million decision. And believe me, a lot of customers that we see would have to make a much bigger cost decision than that. So that's really what we want to avoid. So in the northbound stuff, those are the patterns, but in order to do that, that agile private interconnect, I need to be able to go and attach to one of these cloud vendors, or maybe others, whenever I want. I can't have to call a network service provider and say, yeah, I'm going to sign up for a year's connection to, Amazon for, at 10 gig that I may not use. I need to be able to turn that thing on, get billed for it by the day or by the hour, and get out. Cloud-like consumption of physical interconnection. This didn't exist 4 or 5 years ago, right? Now, what does that have to do with storage? If I'm a storage provider and I have replication capabilities, right? Storage vendors have to figure out that customers are trying to create these outcomes, these hybrid multi-cloud outcomes. They don't necessarily know how to do all these different things across domains. But if we could automate and orchestrate as we go and take our physical storage devices, instantiate our cloud versions of our storage devices, and we can incorporate the interconnect between them and solve for the most optimal, lowest latency connections that we can count on, we could create the outcomes for these customers without asking them to create them themselves. We turn the customers into integrators, we're going to fail as storage vendors, okay? And their partners. Now, I'm going to go talk a little bit about southbound, which is just as important in the AI world. So as we talk to edge to core to cloud, edge on the bottom, core in the middle, cloud at the top. At the edge, right, you saw the map of all the places that we had. The company's going to have their main core places in a couple of those dots, but they're going to have locality with their users and applications and ecosystem partners and vendors, whoever else they're going to use in all those other metros. And so they have to be able to connect to those things. So we have that capability. Others have that capability, right? In order to deal with that, customers don't want to be sending hardware all over the place. So what they're doing is they're using capabilities like bare metal to instantiate software-defined storage, and then we're still doing the same kind of ideas that we do core to cloud, core to edge, right? Where we are going to replicate sets of data either through data management applications, through database applications, layer 7 stuff, or whatever we have. And once we have the data down there, right, that's where we're connecting to the latest technologies of getting to the far edge devices or 5G stuff. Now, we have a big hand in all that, but it's the whole thing together is how enterprises are using this. Now, the data motion patterns that we talk about getting from core to our metro edges are fairly generic, right? It's just basically 1 to N asynchronous, N to 1 asynchronous, right? And also global namespace solutions like the Panzors and the Sunis that are out there. For different use cases. So again, we're not prescribing any specific vendor here, but these are the kinds of capabilities in general that storage vendors, those 7 data motions, have to be managed along with the interconnection that allows them, right? The customers take care of the locality. The storage vendors need to start incorporating the idea of the interconnect and the different data motion patterns that the customers are using to avoid egress, maintain control, and grab new opportunities. I'm not going to go through these. I put another slide in here kind of talking about each of the patterns defined for anyone who wants to download these slides. And again, I'm going to press on this point a little bit. Let's see how much time I got. Getting pretty good. Cloud cost rationalization is probably the one we're seeing the most, right? And really having that multi-cloud pivot point, if you're going to focus on one thing, this is the thing I would focus on the most because this is what customers are asking for the most. With the cloud rationalization. We're seeing more of this than anything else around the entire world. We're seeing RFPs come in from names of companies that you know saying, here's how we want to architect this, here's how we want to use our data. And it's essentially this. They don't draw it out like this, but this is essentially what they're saying. And like I said, we believe our prediction 2 years ago was that customers were going to get to this either proactively or passively. And it's not like a customer is going to say, I'm throwing everything out, I'm going to do this. Every incremental decision they make when they buy a new storage device, when they do a new application, when they do a new project, will be done consistent with this. That's how they get into this. And over time, more will get into this model than not. I'm not going to get into our products, but I'll talk about a specific customer that I'm allowed to talk about in our connected vehicle ecosystem. And this is a kind of a permutation of that, right? These guys used, we don't say Azure here anywhere, but it's Azure, where they're bringing data in, they're keeping custody of car telemetry data, they're driving cars around doing testing, and they're doing something called hardware in the loop testing, and they're keeping the data in custody because they don't want anybody else to have it. They want to be able to use that data in services they don't even know exist yet. But they'll throw a copy of that data up into Azure to use it for the hardware in the loop, right? And they'll use our Equinix Fabric, which is our agile private interconnect capability to do that, right? And the idea is that the vendors, like I'll give you an example of Equinix's cloud on-ramps, right? So you see kind of in all of these different regions, right? As these being Silicon Valley, LD's London, for instance, Tokyo, FR is Frankfurt, not France. You see the different colors of the different cloud service providers that can be reached within 2 milliseconds from any of those regions. This is what customers want to take advantage of. Okay, that optionality. I may want to use Google in Frankfurt next week. How do I try it out? This is what they want to put themselves in position to do. The storage vendors can enable this through the intelligent data motion and interconnection if they choose to, right? So the calls to action. Again, they're very soft. When you're designing higher level functionality into the storage appliances and stuff, and again, I understand there's a lot of the lower level protocols people here, so this is for your friends in those other departments. Consider the transport, the interconnect. How am I getting data from A to B? Don't just assume it's going to happen, right? We have ways now to give API-driven access to locality data. Where does the storage thing sit? What ability does it have to connect to the different cloud providers locally so that a storage can be aware? Where can I put my stuff? These are things that can be used to do that. And I'm going to give out a quick shout out to the Swordfish and Sunfish folks, because they are, I can imagine a world where after they get done with their current implementation, they could add extensions to the Swordfish protocol to instantiate and query this kind of stuff and manage these types of functionalities in an open way, right? So again, it's not just about cloud APIs, but there are now APIs that can be consumed from companies like Equinix to query as well as instantiate interconnection, right? Automate the patterns that I'm talking about. If you can figure out a way to automate the patterns and help your customers avoid egress, they're going to have a reason to buy your stuff, right? If you're a software-defined storage vendor, right? Make sure that you are not limiting yourself to cloud as the place you're going to put your stuff. Bare metal, not just ours, but any bare metal. Figure out how to instantiate bare metal for your purposes, because bare metal is going to accelerate in usage, especially as we start getting into more edge-to-core cloud use cases, especially as 5G starts to really roll in and become more ubiquitous. And I already brought up Swordfish. So essentially, consider the real call to action is consider locality and interconnectivity as part of your data motion patterns and figure out how to get these best practices. These are what your customers are doing with your stuff. Figure out how to automate this for them, and you will have happier customers. And if you need, obviously you want to work with your partners like Equinix to do that. And that's it. Appreciate it. Any questions?
In your, project and delete model, you can trust them to actually have deleted the data?
If you're using the cloud today, you're trusting them. So all things equal, yes. Right. But to your point, right, if it's compliant data that, I absolutely agree. Now that's where the data sovereignty definition that the cloud providers put out there, if you have the keys and control them and you have full control over the access, I'd argue that's impossible for the cloud, but that's my opinion. But if you ascribe to that theory, then you can, at least it's an industry-wide accepted theory, so you can sit on that if you wish.
Your authoritative data core, the middle that you had, you showed that replicated instance.
Mm-hmm.
I guess two questions. One, relative for that example you gave, what would be the cost delta to do that relative to the other costs that you gave? And would it be co-located in, like say in this case, the Frankfurt example?
Mm-hmm.
Or would it be at some optimal location where you get your network?
It's a great question. So let's compare the two models, right? So if I'm an AWS and I'll use AWS because I just let it out. So it's AWS and I got the 30 petabytes and I have it in one availability zone in S3. And I need another copy of that somewhere. I'm going to send that to another region. Well, I'm going to pay inter-region transit costs for that. It's not going to be cheap. And I'm going to have to pay a second instance, which I'd have to do anyway. Okay, but the transit costs get me, right? And I'm still stuck in one place. If I want to go do something else, I can't. So I haven't met all my precepts. If I move that data out, or let's say if I had that data out in the authoritative core model, I would have co-location in Frankfurt, have that storage either capitally purchased or maybe OpEx through a vendor, right? And then because it's Germany, let's say it's, and I have to comply with that rule, let's say it's that kind of data, I would go to Munich and have another set of data over there, replicate between the two, right? Over a private interconnect, which would not be metered transit. You'd be paying a fee over a fabric like ours. It isn't tariffed like a telco, so it's much, much less expensive, and you could get up to 10 gigabits per second or do multiple of those, right? So the point is, though, is that you would have it's not only do you have your data custody in both Frankfurt and Munich, but you also have a deterministic path between the two that you know exactly where that data is going and how. That you could also encrypt that if you wanted to, right? So full control and auditability versus up there, right? Again, up there isn't bad. I'm not saying it's bad, but it just has limitations to what you can expect, right?
Can you address the IOPS cost, which is another element on top of the cloud?
Well, I mean, if you're dealing with, there's different types of storage at AWS, for instance. I don't want to pick on AWS because all the cloud vendors have a version of this, right? You've got S3, which has API costs, right? So if you've, again, that 1.2 million did include API costs as well as egress costs. So when you're, you know, you get a certain number of API costs for free per month, but after that you start getting killed. If you're in a glacial mode, right, then you get it from API call number one. You have your retrieval costs. The thing is, you kind of get, you know, death by a million mosquito bites on these different costs that they get you, right? But then there's the other types of storage. You got EBS and different versions of that, and if you've got high performance storage, you're going to pay for that. With co-located storage that you're using, you're getting the hardware, and you know the profile, what it is, and it's all single tenant. It's yours, right? Now, obviously, yeah, there's a benefit to having a shared environment where you benefit from scale and your stuff's in with everybody else, but what the cost rationalization movement is all about is, you know what, it actually is cheaper from a price performance perspective to put it on my own stuff in some cases, especially as you start getting big in scale. When you start getting to the petabyte or larger scale, it is absolutely cheaper to maintain it yourself. Absolutely. And then you have a choice of whether to do the processing against that storage right there, or do one of the motions and put it up in the cloud, let them do it, and then get out when you're done. And really using cloud for what it's good for, when it's good for it. Right?
I'm not sure I understood the definition of data sovereignty. Is that
You and most of the industry.
national sovereignty or the organization that controls the data?
Yeah, so sovereignty is a tough word because you're right. It has been used in multiple ways. That's why I prefer data custody,
Okay.
right? Data sovereignty is really more about, I mean, like I said, the definition of data sovereignty that the clouds have used is those two things. You have full encryption. It's the sovereignty from the cloud, that you control the data. That's what they mean. But to your point, national sovereignty is really the more important, I believe, and from what we see with our global customers, especially with all the competing compliance regimes. That's more important to think about, and quite frankly scares people more than the data sovereignty piece.
Because the penalties can be so much worse?
Well, in some countries it can be really bad.
Okay, and so what's driving that is not just the things like the Great Firewall, where we don't want people out there to be able to, you know, communicate with our people. It's more like we don't want our data anywhere that doesn't provide us good privacy control.
Just look at the Facebook fines, right? Just look at the latest Meta fines, right? It's no company wants to be that company that gets whacked. It'll happen. It will definitely happen. And of course, cybersecurity plays into that. Having control of your own data means you can do forensics down to the firmware level of that storage. If you're in the cloud and you get hacked, you can't really do forensics you don't know if the lower level hardware has been hacked. You have no idea. You can't have access to it.
And that kind of moves toward the attestation ideas we're seeing in certain standards now.
Mm-hmm.
So those can be used for that purpose as well.
Any other questions? We've got one minute left. We're good? I appreciate your time. Thank you very much.